Good morning and welcome to Pebble, Bluff, New Jersey. We are about 3 kilometers north of the town of Milford, New Jersey. Scenic vista on the Delaware River on Milford-Regalsville Road. This has been dubbed Pebble Bluff for obvious reasons. There are pebbles and cobbles here, making up what was always classically interpreted as an alluvial fan deposit, because this conglomeratic was often dubbed a fanglomerate. And it even had a separate formational name called the Hammer Creek Formation to distinguish it from the rather monotonous, if not boring, shales of the supposedly underlying Passaic Formation. The Passaic Formation, as you'll see in some of the video, is outcrops down here, classically red beds with some very faint cycles in them. What was interesting about these is that Paul Olson from Lamont Doherty Earth Observatory at Columbia University first interpreted these as basically a facies within the Passaic Formation. And although the sedimentologists have always found these deposits here, these conglomeratic deposits, very interesting, when we look in more detail, there's a much more interesting story here. At the beginning, but we are not very far from the border fault. According to Paul Olson, we are 2.4 kilometers from the border fault. And this is material that is coming off of the uplifted block, okay, and into this basin, probably through a series of what we call relay ramps, to where the streams come in and feed these large streams, and ephemeral flows, debris flows, come in and feed into the basin. The basin in general is dry, with exceptions of when lake levels rise. So when this basin is quite dry, a sudden heavy precipitation would result in the release of basically debris flows. When there's more sustained precipitation, you may get small streams depositing flows like this. So cross-bedded sandstones, okay, and going into more moderately to well-sorted sorted conglomeratic unit. So this is interpreted initially, I think, was by Joe Schmoo, the U.S. Geological Survey, as basically offshore berms in the lake, so shallow lake deposits with wave influence, cross beds, and actually offshore bars of gravel going into a deep lake down here. Now we're going to back up and look at the section below this, and what we'll see is that succession that goes from cobbles to cross-bedded sandstones to black shales, that we begin, as we come out of the black shale, we see a repetition of that succession downward. And in Walder's law, the lateral variations that we see are vertical variations. So if you zoom in, you can see these cobbles are oriented in all kinds of directions, different directions. It is basically no uniform direction like you would expect in a stream. These are sub-randed cobbles that have been just deposited probably in a series of debris flows. These may be, in fact, individual flows. Here's one that goes into more of a sandstone, has more debris flow. This may be better sorted and may be, in fact, more from an ephemeral stream. But this series of debris flows has interested geologists, in particular sedimentologists, here at Pebble Bluff, and generations of students have come here and examined these, described the class, and described the orientation. So this is what caught the imagination of geologists. Some of these clasts include Devonian sandstones, classically known in England as the Old Red Sandstone, but in the United States, the counterpart on the other side of the Acadian Mountains we know as the Catskill Delta facies, which is not one single delta, but many deltas. And the question was always, how did this material come here? It was not transported all the way from upstate New York. And the answer is that there were Paleozoic strata, probably exposed on the uplifted block on the other side of the border fault, and it brought this the kilometer scale away, not the tens to 100-kilometer scale of coming from the Catskills. So that always mystified geologists too, that these purplish, when we get some of these grains, you can see that they are in fact sandstone cobbles. Most of them are quartz though. Pointing at the black shale, and as we come down section, we can see this bed consisting of granuliferous, maybe a little bit pebbly, cross-bedded sandstones. This again is returning to the lake margin. And then going down into, you can see this heavily pockmarked surface. This heavily pockmarked surface probably originally had caliche, which is a carbonate deposited as a soil. So there were soils. This was originally a paleosol, and that's telling us that we are then subaerial, no longer in the lake. So think about the succession going up. A paleosol here, a lake margin there, coming up into a deep perennial lake, a lake margin, and then going into fluvial gravels. So what's interesting then, as we go down into this bed, we see it pebbly and moderately to well-sorted pebbles in this bed, which is interpreted again as more of a stream deposit. As we go further down, we begin to see larger and larger. So just to remind you, cobbles are from the size approximately of a tennis ball to about the size of the basketball. Most of these large clasts are cobbles. And this, they're irregular in terms of their distribution. Okay, this is probably just a debris flow deposit. So we went from debris flow deposits to stream deposits to shallow lake deposits to deep lake deposits to shallow lake deposits and back to stream deposits. That's the vertical succession that we see here in this part of Pebble Bluff. We're now going to walk this section and look at the facies along the way, and what's most interesting is that we come back to something similar to this as we move down section. So this particular clast approaches certainly almost boulder level. So we can see that this material here is particularly poorly sorted. If you look at this, vertical clasts here, this is clearly a debris flow deposit. As you come down though, you see this sandstone, shaly sandstone here, cross-bedded sandstone here. So this is clearly an alluvial deposit. That is to say, stream, fluvial. Okay, moved by water with generally one direction. And then we come back into poorly sorted, look at that, angular grains, randomly oriented. Look at the orientation here versus the orientation here. So if we look at these orientation of these grains, they're irregular, random, and this is a debris flow deposit, or as I like to call it, a garbage can facies. Just like you took a garbage can and dumped it upside down, clasts of all different size. The process of debris flow versus the process of a more unidirectional stream fluid flow. So you can see that very irregular bed with clasts in it. Oh, it pinches into a sandstone here. Okay. And then into another cross-bedded sandstone. Okay, you can see the cross beds here. Cross-bedded sandstone. Cross-bedded sandstone with clasts that have been reworked and into preferentially oriented. This is basically lake margin again. And I should add, it's possible that instead of being a fluvial deposit, that this could be lake margin here. But this is clearly lake margin. You can see the cross beds of the material. The clasts are oriented in one direction. We're coming down, and guess what's here? This is our black shell again. We can dig this out and pull out pieces of the shell. And you can see that this, again, is our black shell, making this invagination into the cliff. So the facies that we see are black shell facies, cross-bedded sandstone, intercalated cross-bedded sandstones, and randomly oriented clasts of cobbles, even going into boulders just above this. So this is a cycle. We take it from the shell here to the shell where we started. We have come from about 14 meters up in the section to about 7 meters in this section. This is about a 7 meter thick unit that we just took you through. And it reflects, again, perennial or deep lakes, the shallow lake margin, debris flows perhaps building into the lake, perhaps some streams going into the lake, or these could in fact just be lake margin with the debris flows building in. And then more massive domination by debris flow. Now think of this in terms of evaporation and precipitation. Okay, the lake only exists because there's high precipitation relative to evaporation. It's perennial. As the lake shallows into the lake margin, it then is reflecting, it is becoming drier. And then drier yet as we move into the debris flows. So this cyclicity exists here at Pebble Bluff. We can see this in deep lakes of the Locaton Formation, but we can also see them in a more subtle expression in the red shale facies of the Passaic. This is the conglomeratic facies of the Passaic here. The dominant facies of the Passaic are red shale, as exemplified by anywhere you walk around Rutgers campus. And that red shale also shows cycles, but they're much more subtle. Sometimes they're very difficult to see. And we will look at one of those further down the road in a few minutes. So this is one or more debris flows. It actually looks like to me that there could be a couple debris flows. This is an irregular surface with, you can see the imbrication, no given direction, random. Then all of a sudden, the pebbles here are oriented. This could, in fact, just be an exposure horizon with another debris flow on top of it, and then another debris flow on top of it, and then another debris flow on top of it. Then we go here into the sandstones here. And these sandstones are interpreted as most likely due to more, again, stream deposits, well sorted. Material in the sandstone is very well sorted. Okay, occasional classed at random angles, but in general well sorted with the streams flowing in one direction. Again, a little debris flow deposits going down into better sorted, and then another debris flow deposit here. So some of these pock marks are just due to weathering out of pebbles, but some of the heavily pockmarked surfaces are probably reflecting caliche eroding out. And we're going to look for a few of this. This may be one. Contact here with all these pockmarks. This was on a soil surface. This was a soil here. with a debris flow on top of it. And then we had a series of, these could be debris flows, they could be stream flows, but you can see there are a lot of these caliche surfaces which are telling you these are heavily soilified. So we have paleosols here telling us that we have mostly exposure of the landscape through time. So as you can see in this outcrop right there, there's heavily brecciated, probably just weathering out of a lot of these caliche horizons. Again, mostly debris flows here. And somebody's drilled in here to put explosives. This is probably when the road was made. This not a burrow, it's a drill mark. So we saw one cycle coming up, and a good question would be, where's this next cycle? So I paced off from the first shale to the second shale, and I got about 42 paces, which is about, with my pace, about 38 meters along the road. The strata dipped into the border fault by about 10 degrees. So if you do trigonometry, remember that from high school, it would be an arctangent about 0.17, which means that's about 7 meters of thickness. So I then paced off another 42 paces, and it brings me here. And we can see there is no black shale, but we have these facies here with the cross-bedded sandstones here. These cross-bedded sandstones could in fact be lake margin deposits again, and the lake never got sufficiently deep to record the black shales. So it's mostly, as we come up section, using Walder's law, we still see a repetition of facies, but we've lost the black shale. So now we're looking at typical red shales of the Passaic Formation. A few clasts in them, but these are crumbly black shales, some bedding, but in general pretty crumbly. And these are basically interpreted as shallow lake to playa type lake, ephemeral lake, with lots of caliche and soil horizons in them. And we're beginning to get out of the more conglomeratic facies. This is probably when the material was building into the basin. Remember, these are tilted to the northwest. There was some original depositional tilt to them, but the material is building into the basin from behind us.
Yep. Okay,
there's several facies in this spectacular cliff. One is this cross-bedded sandstone. Predominant direction to the northwest, but there are hints of beds going the other direction. We obviously have the conglomeratic unit. Looks more debris flowish to me. The class seems somewhat random. More debris flow deposit there, and then you see the crumbly red shales up there of the typical, what I call typical Passaic Formation, those crumbly red shales. I'd interpret this as lake margin again, with sandstones dipping both directions, preferentially potentially on shore. Debris flows building into this lake, but the lake generally shallowing upward until that crumble fabric is telling us that it's been repeatedly desiccated to playa lake. And then if we look above that, you can see numerous debris flows coming in with intercalations of finer grained material. If you pan up to this and just go up there, there is actually a fault, a small offset picked out by the vegetation. I was remarking to Lauren, the vegetation is very smart and knows where the faults are. It grows preferentially in the fault. So there's a slight offset, just a couple feet. But then you can see there is that same cross-bedded unit, and up here you can see the cross beds quite distinctly filling in a trough of some sort here. That could be an effluvial environment, but to me it looks more like it's probably a custom. And then as we go up into this massive cliff with numerous debris flow deposits. So this, to me, is that, again, we've hit one of these lake cycles, caught a piece of it here, as we are about, 3/10 of a mile toward Milford from where we started out. We're now going to go toward the town of Milford and look at the section below, which doesn't have these coarse-grained facies. Okay, we're about 1.2 miles to the south, closer to the town of Milford. So we're down section significant amount. We are now in exclusively red beds with no conglomerates. This is the classic Passaic formation. It's probably the member that's older than the Percy, so we can look that up. But what's remarkable here is, in general, I find the Passaic formation about as boring as you can find it, with not great sediment structures, but there are very good sediment structures here. There is a crossbed here in these amongst the shale partings, so this is probably sandy mud, slightly sandy mud here. Okay, so we have crossbeds going like this, and there's even a hint of crossbeds going in the other direction. So they're going this way here, and here there's a little trough, and if you can see the partings going this way, that's the opposite direction. So these are probably the excluded as fluvial. They are shallow lake crossbeds, and if you see this cross-bedded unit, shallow lake, sits on this crumbly fabric. This is what we think of as the classic Passaic. So this is the playa lake, ephemerally covered with water and then desiccated, and resulting in this brecciated fabric going into a shallow lake. And if you follow along here, we can trace this bed, and perhaps in the sunlight you can see the cross beds here spectacularly developed in this shale. And it is still most likely a shale. There may be a little bit of sand in this. Okay, some of these beds washing out maybe slightly sandier, but it's predominantly a shale. And we can see that this goes up and continues in this shallow lake environment. Some more cross beds up there. We're going to walk down section now. Walking down will put us progressively further down into the crumbly beds and see if we see a repetition of the faces. And this is that same contact between the cross-bedded faces. Again, here's a trough cross-bed. Here's planer to slightly, almost in the opposite direction. And here's this crumbly fabric that you actually can begin to see some of the primary stratification. Here, this was certainly a paleosol developed on top, perhaps a shallow lake. You can see this part, this bed, is it a bed or a laminate? It's a bed going all the way across. But as we get further up, these have all been soilified. So this is a shallow lake that was ephemerally exposed. And as you continue along, we're going to walk around the car. This crumbly fabric continues. The beds are all fairly slowly dipping. And as we come down to this point here, you begin to see a more, right by this red car, you begin to see a more massive bed here again. And if we follow that along, we can see it exposed here. And again, this isn't as spectacular, but this is certainly more of a massive bed, less of this crumbly fabric, faint hits cross bed So if we look back that way now, if you pan across toward where the car is, you can see much of the cycle. Right at the foot by the car is the top of the cycle, going into the crumbly fabric and going into the cross beds, and then of course at the very top goes back into crumbly fabric, which makes the talus slope. So that is a cycle in these red shallow water lake deposits.